When it's given that a graph is Eulerian, that means for every node, even number of arcs are connected. In that case, that graph is traversable, which means if we put the pen on a particular node, we can traverse over every arc and come back to the original node. So here is an example. This is an Eulerian graph. So we can start from any point and come back to the point. Let's start from the point A. So it would be A, B, C, D, E, F, then B, C, then E, F, and back to A. Now the same graph can have more than one traversable path, traversable route. For example, this one we can start at A. So B, F, E, C, B, C, D, E, F, and back to A. So here the route would be so we have different traversable routes for the same graph, and it doesn't really matter that you have to find a specific traversable path. There can be many. Here is another Eulerian graph and we have to traverse it. So if we start from A, so we can go A, C, B, A, G, B, F, G, D, F, E, D, and back to A. Here is another Eulerian graph. Now, when we have an Eulerian graph and we have to traverse the graph, sometimes they mention which node to start and sometimes they don't mention which node to start. In that case, it doesn't really matter. Suppose we start at L. So what we can do is L, M, R, P, M, N, P, Q, R, L. Now for the same graph, if we start from L again, we can even traverse the entire graph using a different path. So we can take L, M, N, P, Q, R, P, M, R, L. Now that doesn't mean it is a necessity to always start from the same letter. We can start from any other node. We can also start from Q. So we can traverse the graph by Q, R, L, M, R, P, M, N, P, Q. So here is another Eulerian graph that needs to be traversed. So we can traverse if we start from A, B, C, A, F, C, E, G, H, F, D, A. Now suppose in this particular graph you're asked to show whether this graph is indeed Eulerian or not. To do that, you first have to form a table with one row naming the vertices and the other row naming the number of arcs in the vertices. So first you count how many arcs there are in the vertex. So A has 4 arcs connected to it. B also has 4 arcs connected to it. So 1, 2, 3, 4. C has 2 arcs connected to it. So C has 1, 2. D has 4 arcs connected to it. E has 2 arcs connected to it. F has 4 arcs connected to it. And G also has 4 arcs connected to it. Since every vertex has even number of arcs connected to it, that means the valency of every vertex is even, we can call that it's an Eulerian graph. So now let's traverse the graph. Now since it doesn't really matter where we start, we will also always be able to traverse it if it's Eulerian graph, but we prefer to follow the alphabetical order. So we usually start from A. So if you want to traverse this, so we can do this A, C, F, A, B, E, G, B, D, G, F, D, A.
you.